class today? Lesson 11. So ionic crystal structures, like I said, ionic bonds are strong chemical bonds that results from the mutual attraction between cations and anions. We've been drawing that. When in their solid form, they form a crystal lattice. That's important, okay? They form this crystal lattice, and it's an alternating three-dimensional arrangement of cations and anions. It looks a little something like this, okay? I think we're good there, yes? You don't have to copy this. It's, again, in Google Classroom, okay? But this is what all ionic compounds look like this. And I don't care if it's magnesium fluor, Mg2+, and F- and F-, or calcium sulfate, or whatever, okay? It doesn't matter what the ionic compound, what the formula is. They all basically look like this, okay? So there might be a little bit more, might be a little bit more space in between them to get the right kind of ratios and stuff, but generally speaking, they look like this, all right? Alternating three-dimensional cubey looking shape, okay? Just plus minus, plus minus. There's the sodium ions, they're the black spheres here, and then the white ones or the gray ones are the chlorides, yes? And it's just opposites attract. And there's billions of them. There's billions of attractions. Like, you got to remember that, hey, this sodium attracts that, sure, and that, and that, and that, and there's probably one on the inside that you can't see, you know? So there's millions and millions of attractions, and that's why they stick together so well, and that's why they're, of course, in what form? In room temperature, they're always in solid form, yes? They stick together really well, okay? There's a few more diagrams there, whatever. Okay, we don't need to copy that, but it's true. This strong network of ion attraction influences many properties. So we are going to copy this. Ionic compounds have a very high melting and boiling point. Okay, so again, ionic compounds have very high melting points and boiling points. We're going to look at a chart later on that kind of indicates that. We've talked about that before. It takes a lot of energy, like maybe 800 degrees Celsius, to melt an ionic compound. Many ionic compounds are easily dissolved in water because water is polar, and polar, the opposite ends, water has a little bit of a negative and a positive end. Remember that from Science 10, okay, cohesion adhesion stuff. We have a special name for that. We're going to talk about water. Water's pretty special. But water can pull ionic compounds apart sometimes, and that really depends on solubility chart, yes, which remember on the back of the periodic table. Many ionic compounds are dissolved easily in water. Ionic compounds can act as electrolytes. So when you do pull them apart in water, when they're dissolved in water or when melted, at this point, ions are free to move around, allowing for the conduction of electricity. So that's pretty important too. We know that ionic compounds are very good conductors of electricity, yes? Okay. Well, sometimes poor, actually. I guess we should say that as well. But they always conduct. That's the important part. Ionic compounds are brittle. If they are bent or chiseled, same charged ions come together, repel each other, and then they break. Ionic compounds are, they hold together really well. That's great. They, there's high melting points. It takes a lot of energy to break them. But if you were to bend them or chisel them or hammer them, okay, like charges start to line up. And if you get enough of those like charges that line up, because we've shifted these ions around, then they're going to break. And they tend to break in a smooth line, basically a smooth plane, we say. All right, because it's three-dimensional, of course. But if, I mean, you don't know what that is. Oh, wait, I know. It's huh? It's a hammer, obviously. Oh, you're probably missing here. You're probably missing the little handle things there that kind of. There you go. Okay, that's a hammer. Do I have to explain that to you, really? Okay, that's obviously a hammer. Okay, when you hammer on these are bent. What? What's wrong with my hammer? Maybe it's just a little jammed up there. Let's try it again right here. Hammer. Okay. Sorry, I always forget the claws there. Claw hammer. Okay, that's where you pull the nails out, right? Obviously. Hammer. Yes. Okay. Does that make it better? Why are you looking at me like you're confused? It's a hammer, obviously. Okay, it's a hammer. Okay, trust me. right? I mean, you don't see it. It's a, I'm telling you. Oh, whoa, I forgot this part again here. There we go. There we go. All right. A bird eating out of a bucket? What? No, it's a hammer. What's a? It's a. I, it's a hammer. Not a diving board or a birdie. Birdie hammer. If you hammer on these ionic compounds, obviously, seriously, jeez. And don't try and show me up on the test and be like, "Well, this is a hammer." Oh, I shouldn't have said that. No, yeah, you didn't hear that from me. Anyway, you know, keep it on the DL. Okay, that's down low, if you know what I'm saying. Like, we don't talk about that stuff, test stuff. But if you're like, you know, you got to draw a hammer someday, that's a hammer. And if you hammer on these ionic compounds, you shift them down, okay? And so what happens is we end up with this kind of thing. There's your left row there, there's the middle one. And then, of course, we shift them down so it looks kind of like this. Well, now, these like charges, if there's enough of them, okay, they will build up those repulsive, you know what happens when you take a magnet and try to push it together. One way goes like shrink and it just sucks together, right? But you turn it around, you try to push it together. It's like the funnest game ever. I don't know if about you, but I do that for like hours every night, kind of thing. You turn the hat. People are laughing. That wasn't really a joke, but okay. We'll go with that. Anyway, you try to push them together, and it's like, oh, you know, oh, I got it this time. Oh, you know. And the stronger the magnet is, like the harder it is to push together. It's fun. Try it. Okay. It beats YouTube. That's overrated. Oh, speaking of YouTube, I don't know if you checked lately, but I did. 160 million subscribers as of today. The M is missing. That's the glitch in the program, just like my smartboard. 160. Yeah, I'm just saying, it's gone. See, I lost one the other day. But I said you have to lose one to gain a couple, and that's what happened. A couple million. YouTube checks are outstanding. I think. I don't know. Okay, but plus, you know, like they start to line up, and then that causes them to break. And they usually break in smooth planes, we say, like which is a plane, yes, line kind of thing, three-dimensional line. All right, we're not going to copy that. Let's see, where are we here? Do we need anything else here? No, we don't need that either. No, we don't need that. All right, I think we're done. Yeah, see, I told you, not that bad. All right.